Hi, I'm Harrison Jenkins. I'm a junior here studying mechanical engineering, and I'm looking to minor in aerospace engineering, and I'm on the Lehigh football team. I was an extraterrestrial simulants intern at NASA's Jet Propulsion lab this summer. JPL in particular is famous for unmanned spaceflight, which is robotic spaceflight. People aren't controlling it. It's, things have to work either autonomously or just robotically. And that's really one of my biggest interests is robotics and how that merges with aerospace. So across the lab, there's what's called test beds all over the place, and a test bed is just like a test setup. The one that I was really working with was like a really big freezer room. So we're able to move robots and different test setups into that freezer room, and it goes down to like -40°C, and we're able to get those thermal considerations mapped out while things are testing and things of that nature. But there's a lot of things that go into maintaining that freezer, and especially during the summer. It's something that when you have so much thermal mass coming in from outside, it can really do damage to like the efficiency and things of that nature. So a lot of my projects centered around keeping that freezer room cool and developing solutions to mitigate like the thermal radiation from coming into the room. But one of the biggest things that I'm most proud of, and what ended up being like one of my biggest projects, was creating like an app and setting up a network of sensors inside of that freezer room to help us get a better characterization of like the thermal gradients within that room. When we got that freezer, there was only one temperature sensor, which we call a thermocouple, in that room, and it happened to be located on like the defrost coils. And the defrost coils basically heat up, right, to melt the frost that kind of aggregates on them. So you can imagine that when that sensor is on those coils and it heats up, it looks like the freezer, which is supposed to be at -20, is now at 20–30°C, which is way hotter than we would want it to be. So I went in and was able to set up a network of thermocouples and then route them to what we call a data acquisition device. And that device just reads the temperatures and digitizes it. And then I was able to hook that into a computer and write the code to actually create like a visual model of the freezer and display those thermal gradients in a way that we can track how it's changing throughout the temperature, how it responds to people opening and closing the door, to different machinery being in there, and most importantly to help us understand that when it goes through a defrost cycle, things aren't blowing up inside and killing the machinery in there. When I started this project, I only had a few weeks left on my internship, and people were kind of like, don't get too ambitious, and we want to make sure we can finish this before things start. And the football player in me said, I'm gonna do this, and takes it as a challenge. And my faith is so important to me, and so looking to God throughout the entire summer, but especially in those moments for, okay, God, just help me get this little improvement and help me to solve this problem. And so one step at a time, seeing those improvements was really rewarding. But then finally, when there's maybe a week left or so and it's really crunch time and getting it to work for the first time together with the sensor data, and to get that information for myself and see, actually visualize the trends that are happening in the freezer and make sense of those gradients, and just having things click for the first time, it was incredibly gratifying. And also it was really satisfying to feel like maybe I added some value to that space at JPL.